which is the umbrella under which we're doing this work. And we're also part of the Asahi Linux project and maintain Fedora Asahi Remix on the Fedora side. So before we go into the CentOS specifics, let's talk about Asahi Linux for a little bit.
Yeah, so Asahi Linux is the upstream project the upstream community project that brings Linux to the contemporary Apple Silicon Mac platform, starting with the M1 in 2020. Over the course of the past 3 years, it has grown with a number of people now. I think we're at like nine-ish folks, almost 10. That we have a reference Linux platform that demonstrates that, hey, you can do Linux as a daily pretty well, and it works great. Financial contribution to the project is now possible through Open Collective, so hey, if you like the stuff that we're doing and then the stuff we're talking about now, feel free to chip in. And as I mentioned, we have a reference Linux platform, and that is the Fedora Asahi Remix. It provides the reference platform with all the integration and support and documentation, things like that, and uses KDE Plasma Desktop as a flagship edition, with GNOME as an alternative desktop, as well as server and minimal editions for headless and custom deployments. And we have extensive documentation about how it is assembled, how it works, as well as how to use it and customize it as part of your own deployment.
We released this at Flock in Cork.
Yes.
That was a couple of years back.
Yes, 2023.
Yeah. And it's been available since then. If you install it now, you'll get Fedora 42.
Yep. We've gotten to a point where now we release basically day of the GA release. So
yeah, 42 we got it out on day of. 41 I think it was like a couple of weeks later.
Well, it was because we were at Red Hat Summit.
Yeah, you're right. Yeah.
So we lucked out.
But this talk is not about Fedora, it's about CentOS.
Right, so CentOS and Hyperscale. So,
yes.
Davide, you want to talk about the SIG, and then I'll talk about the deliverables?
As mentioned, we both co-chair the CentOS Hyperscale SIG, which was also featured in the previous talk. Hyperscale is a special interest group within CentOS, and the idea is to provide a space for folks that are interested in helping deploy CentOS in large-scale environments, where that is very loosely defined. Over the years, this has kind of become a place where people that want to do work within CentOS that doesn't quite fit into the mold of the distribution itself or other places have found a home in Hyperscale, and then some of these efforts stay in Hyperscale, some of them branch out to other SIGs, become their own SIGs, or get integrated inside CentOS Stream itself. We do, one of the things the SIG delivers, it delivers a set of package repos, but it also delivers a set of spin images. So there is a live ISO that you can download if you want that puts up a live CentOS Stream running KDE by default. We also have GNOME images.
10.
Oh yeah, not for 10. We don't have GNOME for 10 yet.
That's why I didn't mention
But the idea of this is that this integrates all the things that the SIG provides and does.
Yeah.
And the SIG provides quite a bit of things. As Dan mentioned in the previous talk, we ship a systemd backport that tracks the latest systemd shipped in Fedora, so you get the latest and greatest. We ship an native virtualization stack. We ship a wide variety of what I call like low-level systemd plumbing that is useful, that people find useful, that for one reason or another is set to old versions in Stream itself. We also ship a lot of developer tooling stuff. So things like the latest Emacs, the latest Vim, because people really like having that on their machines where they're doing day-to-day work, and there's no reason not to do that. The other thing with Hyperscale is that we try to kind of expand what the distribution can do and focus on technologies that aren't enabled in RHEL itself, but that we find useful. So we support Btrfs. Btrfs was actually one of the main drivers for doing Hyperscale in the first place. The spins that we ship for Hyperscale have Btrfs enabled by default. They install with Btrfs. The kernel that we ship as part of Hyperscale has Btrfs support. We ship all of the user space stack. Re-enabled. We actually ship Btrfs products in Appel now because it's needed for some container stuff too. And we also ship things that then build on top of this and leverage Btrfs to make the system more efficient, like RPM copy on write, which speeds up considerably package installation. We also do things that we think make sense that for whatever reason are not done upstream, like enabling Appel by default, because why not?
And CRB and all the other things that
and CRB and all the stuff. And we have cloud images.
Right. Like currently we have an OpenStack and an AWS image. Like if other folks are interested in supporting other clouds or want to provide some experience, we can very easily do things like we have definitions for Google Cloud, Azure, and so on. But like right now we have the optimized definitions. We currently just build them for AWS and OpenStack and related, but we can do more as people ask for it and want to use it.
So the reason we looked at Hyperscale for doing this work is, well, both Neal and I are involved in it, and it was an easy place to do the work. But also some of the technologies that we leverage in Hyperscale, specifically ButterFS, are beneficial for this platform and were something we wanted to be available for users.
We wanted to be cooler than macOS.
Well, yes. So now let's talk specifically about Hyperscale Asahi.
Right. So CentOS Hyperscale Asahi, which is a mouthful in itself, is the CentOS stream distribution for Apple Silicon Macs. It provides workstation KDE and server variants, and it targets providing the full CentOS Hyperscale experience leveraging CentOS Stream 10 Hyperscale on Apple Silicon platforms. So we take all the good stuff that we did for Fedora Asahi Remix, and we start pulling that into an enterprise context using CentOS Stream Hyperscale. And this lays the groundwork for potential downstream forks like Red Hat Enterprise Linux or Alma Linux or similar that can take advantage of our technology and ship it to people that are interested in actually doing really cool stuff on ARM platforms where they're stifled by the fact that ARM sucks outside of Apple.
Yeah, one of the reasons we wanted to do this in stream was to make it easier for the wider ecosystem to take advantage of it. And by the way, both of these laptops are running the KDE image right now. So in practice, what we've done is there's two parts primarily to this enablement. There's the user space side, then there's the kernel side, and then there's the platform weirdness stuff. The user space side was easy in this case because all the user space packages were already in Fedora because we have them for the Fedora Asahi Remix. So we just had to branch them for Apple. We're now at the stage where all of the core packages needed to get these machines running are branched. Some of the fringe packages aren't yet out. So for example, you see on this one, the taskbar doesn't work because the taskbar is ran by a little daemon written in Rust that has a bunch of dependencies that we just haven't gotten out in time. But that's just a matter of doing work. The other thing that we branched is the installer and the bootloader. The way these machines work is peculiar in that to install them, you have to start from macOS, and you have to run a thing on macOS that lays the image on disk, and then puts the machine in a special mode that tells it to boot from there. And the way the machine then, basically what this does is that it installs a second copy of macOS, then yanks the kernel out and swaps the kernel out with our bootloader. And then our bootloader mini will boot U-boot. U-boot will boot
Grub.
Well, U-boot will emulate UEFI.
Right.
The emulated UEFI environment will boot grub, and then grub. That just is the standard Fedora boot flow.
Yes.
We use the same installer and the same bootloader we have in Fedora, except we build them with the CentOS logo instead of the Fedora logo, so when you boot the machine, you get the right logo, because branding is important.
Yes.
This was surprisingly tricky to do,
Oh my gosh.
but it does
we
work.
actually wound up doing code changes upstream to support swapping
Yep.
branding.
For U-boot, we can't use the U-boot. Well, U-boot isn't branched for Apple 10, actually. There's a ticket up for that. But also, we can't use the stock U-boot right now because we need a fair bit of downstream enablement changes that aren't upstream in U-boot yet. So we just use the same U-boot that we built for Fedora Asahi Remix, which is built in Copper. We just added a Copper target for Apple 10, and we built it there, and we just use the same one because that was easier. And finally, there's 4 packages that we build in CBS in a dedicated tag as part of the SIG. Asahi scripts, because Asahi scripts depends on U-boot, and U-boot is not in Apple, so we can't build in Apple. The kernel, which Neal will talk about in a minute. And Mesa, because up to very recently, we needed a downstream fork of Mesa to support the GPU. This is going to be going away to some extent now that the GraphicsView API has been merged upstream. And the force package is just a meta package that pulls in all the dependencies to make life a bit easier for people.
And to block packages that break things.
Yes.
So speaking of packages, special packages, we have the kernel, which is derived from the main hyperscale kernel, which itself is derived from Arc, and which follows the rel-ish config, which adds ButterFS and WadeDroid support so that people can do useful things on their desktop and have like a nice similar to Fedora style experience. On top of that, of course, we have to layer the Asahi Linux patch set, and we turn on a bunch of ARM-specific configs that RHEL doesn't have because the Red Hat Enterprise Linux configuration for ARM does not include things like device tree or open firmware support or any of the other stubs, any of the extra drivers. There's a bunch of things that are missing. Like the RHEL ARM platform is very, 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 very basic. It is essentially UEFI style, ACPI standard, the very rare system ready ACPI standard. I think it's called SR or whatever.
This is very much not a system-ready platform.
No, I mean it's gonna be challenging to find system-ready SR platforms. So, but because this is not an SR platform, we need to turn on all the other things that make it a system-ready DT platform, which is what we emulate to be able to run the system. We keep this in sync with the Fedora Asahi Remix kernel, and we have a kernel arc fork, because that's how you have to do it.
The other thing that's relevant for the kernel is these machines natively run it as a page size of 16K, 16K is not a common page size. RHEL on ARM, I believe, still defaults to 64.
Yeah. No, 4K now.
Did we default to 4K now? But we still ship 64 on ARM.
Yeah, 64 is still shipped, but RHEL ships 4K by default. Okay.
And on every other platform runs 4K. The hardware can sort of boot on 4K, but you lose
USB.
You lose everything that's connected to the IOMMU effectively, so it's not.
Which is USB,
it's not
PCI,
great.
SPI, everything.
And this platform is just made to do 16K. It's kind of pointless to not do that.
Yeah. I mean, there's possibly going to be some better news on that front when it comes to ARM, because Apple basically has more or less inadvertently convinced everyone else that 16K is the way that they should go. Android is moving to 16K. Among other things. The Raspberry Pi 5 moved to 16K as their preferred page size. There's also some upstream work that I'm crossing my fingers will eventually land soon. I got to go bug the ARM guy again, which is it'll become reconfigurable at boot time with a boot parameter. So you no longer have a fixed compile time flag for the page size, which would make my life considerably easier.
That would be interesting.
So I'm looking forward to that, because then it changes to which flag do you set by default.
Then we don't need to have a million
then
variants.
I don't have to build the kernel 4 times. Yep. So talking about building things, so all the images we build are done with the Kiwi image build tool, which comes from the wonderful folks at SUSE, as well as myself. And we build like we do with Fedora Asahi Remix. These descriptions were basically forked from CentOS Hyperscale, with mixing in some of the Fedora Asahi Remix stuff. And so we were able to build the base disk images, and I think we're pretty soon going to experiment with providing native UEFI live image boots set up, like to make it more like other ARM platforms and more like x86 system installation. That's hopefully coming soon, and that'll unlock the door for things like, hey, if you want to have a custom partition layout, even if maybe you have a secret hatred for Btrfs and you want something else, you can absolutely do that, or do full disk encryption or any of those other things. Kiwi is also used by Fedora Linux upstream for various desktop, ARM, and cloud server images. And we, as I said earlier, we do it for CentOS Hyperscale, the CentOS Alternative Images, which build all the live images for different desktops, also uses Kiwi. There's a whole lot going on there. If any of you are coming to the OpenSUSE conference, that is in 2 weeks from now, me and David Duncan, who's also in the audience, is giving a talk about how Kiwi is being used in the Red Hat ecosystem with Fedora and CentOS, and how it has made many people's lives easier to actually do cool things.
Yep. As we mentioned earlier, one of the reasons we use Btrfs here is because this is an image install workflow where the installer lays the image on disk. Btrfs supports both online resize and online shrink, and that makes it a lot more easy for users to tweak the partition layout to what they want to, even if they can't do that at the install stage, because the install just plops the image on disk.
Yeah.
At least for the time being. When we'll have the lives in the future, that'll change, and we'll just use Anaconda like everybody else.
Yes, there's a bunch of work to do to Anaconda, but that is on the roadmap.
Yeah. Infrastructure-wise, this mimics the setup we use for Fedora Asahi Remix, where we try to use as much as possible upstream infrastructure, except where we can't. Specifically, we do builds of packages in EPEL and in Copper and in CBS. We don't do builds of the images themselves in CBS, because building the images requires combining artifacts that are built outside of the project, like the kernel, so it's not appropriate to do it there. So what we do is that we have an AWS account for this, and we just use the standard AWS tools that you would use for this. So we have a bunch of Lambdas that orchestrate builds. The builds are actually run on EC2 because the builds take more than 15 minutes, and Lambda will suicide after 15 minutes. We shove the artifacts in S3. We serve the S3 bucket as a website via CloudFront, which provides a CDN in front of it to minimize cost. And then we have a couple of housekeeping Lambdas in the back that do things like caching validations and stuff. This is all open source. It's all very much like thing that was written mostly by me, who has no idea how any of this works. So it is not a good example of how to do AWS work, to be absolutely clear. But it does.
It's worked for 2 years.
It does work so far. It also has no monitoring whatsoever, which we should fix. But look, that's a different problem. Right now, we're just doing manual builds, primarily because we only quite got this pipeline working last week. But we will get automated daily CI builds like we do for Fedora. For Fedora, we have dailies every day that build Rawhide 42 and 41. And we'll do the same thing here, where we'll do dailies that build Stream 10. And then in the future, when 11 comes out, we'll do Stream 11 and so on. And,
I mean, eventually we'll probably also start looking at doing like Fedora ELN.
Yeah, it'd be interesting to do ELN here. We'll need to. There's some challenges with ELN here because we can't target ELN in CBS, and we can't build. We can target ELN from Copper, but we can't build from GitLab in Copper because Copper doesn't support GitLab as a dist-git source for CentOS SIGs.
We also have the other challenge of we can't build the ELN. We can't build our kernel in ELN right now.
Yes, that is also a problem.
Yes, without our kernel in ELN, it becomes very difficult to do hyperscale ELN.
Yeah, but it'll get there. So right now, this mostly works the same way that Fedora would work, in that you can install it on all M1 and M2 laptops and desktops except the Mac Pro, mostly because the Mac Pro is kind of stupid and nobody really has one. It supports, well, the firmware for us is macOS, to be clear in this context, because from the point of view of Linux, macOS is your firmware.
Yep.
And the stub macOS that we install is 13.5.
Yep.
But this supports any macOS effectively installed in the machine, including the beta that came out yesterday.
Yep.
The camera works, HDMI output works, as you can see, because this is what the laptop is doing.
Yep.
There's a nice graphic there that you can look at. There's a few things that are supported by Asahi Linux and are supported on Fedora that are not supported on CentOS. That should be fixed in the next couple of weeks. We don't have hardware accelerated graphics right now because something's wrong with Mesa for some reason.
I'm not sure what's going on here. I have a suspicion that it's something related to the incomplete upgrade of the Vulkan stack, and so or SpearV or whatever, and it didn't get built right. But it's something we're still tracking down.
That should work. We don't have the touch bar because that package needs to be branched. For the speakers and the audio stack in general, all of the user space is branched. But I think we don't need to turn on the kernel driver because the devices don't show up.
Yeah, I probably just missed the config.
For the microphone, we need to branch the user space for that, which is fine, except it's a pile of Rust crates. And we need to branch an algebra, which is also a pile of Rust crates. But we'll get there. As I mentioned, we do build Asahi scripts in CBS instead of upstream in Appel because U-boot isn't there yet, and there's a ticket for U-boot. And finally, on Fedora, we ship OpenH264 for video decoding. We can't do that on CentOS because it doesn't exist yet for CentOS Stream 10 because of issues with Cisco, I believe.
Yes.
But it'll get there eventually. But I would say these are all things that are fixable and will be fixed soon.
Yep.
Once these are sorted out, these will have feature parity with Fedora. And we expect it to continue to have feature parity with Fedora in the future. So if you want to try this, you can just do that now. If you have a Mac, you can run that command from macOS. And what that'll do is that it'll download the installer. The installer will bootstrap itself. It'll offer you to download and install image. It will resize the disk. It will lay the image on disk. It will then reboot the system in recovery and guide you through changing the security settings for the stub macOS install that controls these, and then it'll reboot in Linux. That's what's running on these machines. Please do not file bugs for these on Jira. People will be extremely confused. If you do use this and want to file bugs, please file them in our tracker or find us on Matrix and ask questions there. But don't bug upstream maintainers in CentOS Stream about this because it's going to be very confusing. And I think that's all we had.
Yeah, that's it.
Any questions? Yes.
So I see that you are very close to having feature parity, right? As what you just said.
Mm-hmm. Okay.
So the first question was, how long is it after we close all this through? How long will it take for us to keep things in sync between Fedora Asahi Remix and CentOS Hyperscale Asahi? My expectation is that as soon as things are actually landed in and locked in and working, we're probably talking about maybe a 1 week difference. Yeah. Because quite literally it takes time for me to make the kernels, make sure they're not broken, then push them and then build them and then get the images done. So probably about a 1 week difference between Fedora and CentOS. And
the user space will be updated almost immediately because especially the user space that's in Nepal is trivial when you update it to update it in Nepal. We should file an update exception for that actually, so that the versions are kept in sync. Policy in Nepal is generally to avoid updates if there's no reason, but in this case, it makes a lot of sense to keep the versions in sync, so we'll just do that.
The main inhibitor might actually be the audio stack, because we are dependent on a chainsawed pipe wire.
Yeah, well, so far the audio stack is interesting because the audio stack requires, it's a fairly complex DSP chain that relies on LV2, and RHEL and CentOS Stream do not ship pipewire module LV2. So, and I filed a JIRA asking them to ship it, and they were not interested. So right now, to mitigate these, we have a package in Nepal that ships only the missing sub-package for pipewire. This does work, but this is extremely annoying to maintain. So as long as pipewire doesn't change too much, this will be fine. If the CentOS Stream maintainer does a lot of changes to pipewire, we might need to revisit this because this is going to be
He does a lot of changes
painful. Yeah, so we'll talk to him and figure it out.
Yeah.
It'll be fine.
It gets rebased every cycle. So.
No, on your other question, which was whether CentOS would replace Fedora as the reference platform for Asahi, no.
Replacing Fedora with CentOS as the reference for Asahi doesn't make a lot of sense, in large part because of the friction that is required to actually bring this online. Because of the splinter, we're literally building in 3 separate sources to assemble this platform, and we don't really have a pipeline for integrating anything upstream. It makes for a very poor reference platform.
Yeah.
Fedora is much better at this because, in general, we're able to just get this stuff integrated, and as features are upstreamed into the mainline Linux kernel, we can turn them on, and so it reduces our burden and makes it much easier and much more useful and friendlier for upstream development. In general, I don't personally consider CentOS Stream to be very friendly for upstream development, especially around hardware enablement, because of this particular condition. It makes it somewhat difficult. There are definitely ways to work around it, and I know people that do, but Fedora is a way better platform to develop the future than CentOS is.
Yeah, for Asahi specifically, Asahi Linux, the project has a policy on how distributions can and should integrate, and we just plan to abide to that for CentOS, and CentOS will basically be another distribution that's available on the platform, like Debian or Gentoo or Arch or whatever.
Right. Yes?
Yes?
Actually, that's not the question. I see in Matrix a note which says that the Mac Pro will be supported soon. I'm not sure if this is a reference to your...
Yeah. I mean, there is ongoing work to add support for that.
There is someone who has one.
Yes.
It's just, we don't want to promise it because
yes.
None of the rest of us have it.
But yes.
Unless someone wants to donate a whopping large cash ball.
If you happen to have a Mac Pro as a boat anchor in your house,
yes,
it might become supported soon.
Yes.
Any other questions? Yes.
Yes.
A bit off topic, but you mentioned that everything is moving to 16K page sizes. So do you have any idea why? What is the benefit?
It's a performance to battery life thing. So when you use larger page sizes, it is much easier for workloads to not have to create more pages and having to walk through all this stuff because you can fit more in a memory page. And when it comes to things like, for example, database workloads or GPU, things like that, actually concretely, the NVIDIA driver for ARM recommends that any platform that it's being used on runs in 64K pages. That is because a lot of the workloads that it's associated with are very happy with 64K pages and are less happy with other ones. 16K provides a nice balance between the two because you are able to spend less time going through memory while you still aren't like getting to a point where you're frequently wasting pages. The downside of 64K pages is if you're not using all of it, you're still allocating the memory that you're not using. And so for mobile platforms, being able to do fewer pages that are larger and then optimizing the access around it has an impact on battery life in a positive way. So since most ARM platforms are battery-based, like battery life is the most important aspect, they are moving towards that. 4K was mostly there to be compatible with x86 workloads that are page size specific. Like, you know, if your code, for some reason, hard codes a page size, which it shouldn't, by the way, you should not do that, bad you. But if you did, then having the ability to operate in 4K pages makes your workloads compatible. The other reason to support 4K is so that you can run x86 applications with minimal complication. Because in x86 supports, I believe it is 4K and 1 megabyte as page sizes. And trust me, you don't want to see what it looks like when you use 1 megabyte page size. Yeah, okay. Yes, so it's worse. It's 2 megabytes or 1 gigabyte. Don't do 1 gigabyte page sizes. That's bad. But basically, the compatibility for the 4K page size is basically considered a common baseline across all the different architectures. And that is useful for being able to have applications from other architectures to be able to more seamlessly be able to move over. It basically exists in large part as a compatibility page size.
Yeah.
And most Linux distributions default to it because it makes having to debug handwritten assembly not a thing you have to think about. So it is super not fun when you have to debug page size problems.
We don't ship this for CentOS, but for what it's worth, on Fedora Asahi Linux, we do ship an emulation stack that allows you to run x86 software, including Steam games and stuff. And the way that works is that we use MoVM, which boots a micro VM with a different kernel, which uses 4K pages. And then inside that micro VM, we run FEX, which is an emulator from ARM to x86. And then inside FEX, you run your x86 software, and which in the case of Steam runs Proton runs Wine runs your game.
Yeah, so you've got your Windows up to Wine, up to...
This does work.
Up to Linux, up to there, and then it
works with actually pretty good perf for most things. But yeah.
And people don't even generally notice the launch time for bringing up the micro VM because it's a micro VM. It literally just uses the kernel to initialize a fake hardware platform and then runs the process.
Yeah, we don't ship this on CentOS right now because it wasn't a priority, to be honest, and at least my gut feeling is that most people that will use CentOS on this platform will use it for server workloads. So it seemed kind of silly to dedicate resources on that right now, but it could be made to work on CentOS. It's not that hard.
Yes.
It's mostly a matter of branching like half a dozen packages.
Yeah, I mean, if somebody wants to
and then building the rootfs for FEX.
The FEX rootfs is the other part. Right, so if somebody wants to do like professional, I don't know, Linux 4K applications to run on that or Windows applications, that is definitely a path for that, but it is not one that we are focusing on right now.
Yep. Anything else?
Yeah.
Alvaro.
You say namespace branching for audio drivers. What does that mean?
So he asked, what is namespace branching of the drivers? I don't think...
What do you... Can you elaborate?
2 slides ago.
2 slides ago. Oh, sorry. So by branching we mean... so when you have packages in Fedora, they're not automatically available for Appel. They have to be branched and built. And it's called branch because it's literally a different Git branch. So somebody has to go through the process of making the branch, pushing the package there, doing the build, submitting the update for the package. When it's one package, this takes 5 minutes if the package builds. When it's a RevDep chain of 150 packages, which can happen, as Fabio well knows, then that takes a bit longer. Michel, who's sitting next to you, did write tools to automate this, which is what we use for some of this stuff, but it still takes a while. All right. Any other questions? Going once, going twice?
Sold.
Thanks, everyone.